Good morning, kiddos. Hope you all are having a great day. So today we're going to move on to our next learning target. So our next learning target is that I can add and subtract radicals. So last week we did I can multiply and divide radicals. Now we're doing I can add and subtract. So you can go ahead and title your notes. Adding / subtracting radicals. Let's go ahead and scoot my camera. There we go. That's a little bit better. So adding and subtracting radicals, as always, make sure you're taking good notes. You're pausing if you need to. You're writing down any questions you have to ask me when you're in school tomorrow, as well as you're staying on top of these assignments and actually doing them and taking the notes. So we're dealing with adding and subtracting radicals, and there's just a couple rules. So the rules are, rule number 1 is you have to have the same index. In order to add or subtract. Rule number 2 is you have to have I forgot some words here. You have to have the same index and you have to have the same radicand. So as a refresher, if we remember, we had N and A. What's inside, that's called the radicand. The index is that little N on the outside. So those two things have to be the same in order to be able to add or subtract. So essentially rule number 3 is if they're not, you can't add / subtract. So very similar to multiplication, you first have to check a couple things and then it's just a process of simplifying. So that's an unspoken rule, is you're going to have to simplify your answers, but we're used to that at this point, I hope. So again, learning target, I can add or subtract radicals. I'm making this in advance, but if I remember correctly, we do probably have a quiz coming up soon, if it's not after this learning target, so just be on the lookout for notifications and posts about that. So we'll just go ahead and hop right into some examples. So let's say I have 3 radical x minus 5 radical x. So first I have to check, do they have the same index? There's nothing there, so I assume it's a 2 for a square root. Yes, they have the same index. Is what's inside here the same? Yes, they're both x's. So then I'm able to go ahead and I have 3 radical x minus 5 radical x. So 3 minus 5 is going to give me -2, and then I'm going to be left with that radical x. Okay, so it's just kind of like any other addition or subtraction we've done. 3 minus 5, -2, and that's going to stay the same. All right, so let's check this one. If we have example number 2, if we have 7 times the cube root of 5 plus 12 times the cubed root of 5. Do I have the same index? Yes, they are both cubed roots. Do I have the same thing in the radicand? Yes, I have 5 for both of them. So I'm ready to go ahead and add. 7 plus 12 is going to give me 19. And then I bring over my radical, cubed root of 5. So that's the basics. But again, it does get a little bit trickier after that. So go ahead and we'll do example number 3. Not really trickier, just more steps. I shouldn't say trickier. We're going to have 20 radical x minus 15 radical y. Do they have the same index? Yes, they're both square roots. Do I have the same radicand? No. I have an x in this one and a y in this one. X and y are not the same. So for this one, you simply can't do. Can't do because of this aspect right here. Alrighty, example number 4. The square root of 72 plus radical 32 plus radical 18. So first we check, do we have the same index? Yep, all square roots. Do we have the same radicand? No, we do not, but these are not in simplest form. So we always want what's in our radical to be in simplest form. These are not, so we're going to have to go back to what we've been doing this whole time and start simplifying these radicals. So we'll start with 72. We're going to have 9 and 8, 4 and 2, 2 and 2, and then we're going to have 3 and 3. It's a square root, so we're looking for pairs. I'm left with a 2. So that's going to give me 3 times 2, which is 6, radical 2. Then we'll move on to 32. We'll do 8 and 4, 2 and 2, 4 and 2, 2 and 2, looking for pairs. That's going to give me 2 times 2, which is 4, with 1 2 left over. Plus, move on to 18, 9 and 2, 3 and 3, looking for pairs, 3, radical 2. So at first glance, it looks like we would not be able to do this one, but contrary to popular belief, we are able to. Once you simplify these down, you see that we have a radicand of 2, so we are able to add. So first we'll do 6 plus 4 plus 3. 6 plus 4 is 10, plus 3 equals 13. And then we'll bring over our radical 2. Okay, for the next example, I have ran out of paper. There we go. Right. Example number 5. We'll do 2 more examples and then we'll be done with this video. Radical 75 plus 2 radical 75 minus 5 radical 3. So do I have all the same indexes? Yes, but I do not have simplified radicals. So I'm going to have to do that first. This one has a 3 in there. That one's simplified, so we're just going to have to worry about these 2. We'll start with 75. We'll have 25 and 3, and then 5 and 5 looking for pairs. So this is going to give me 5 radical 3. The good thing about this one is these are the same, so this is also going to be 5 radical 3, but we can't forget about this 2 out here. That's going to be 2 times 5 radical 3 minus 5 radical 3. So that's going to give me 5 radical 3 plus 10 radical 3 minus 5 radical 3. So 5 plus, so now I'm able to add, same index, same radicand. 5 plus 10 is 15, minus 5 is 10. That's going to give me 10 radical 3. Okay. And then we'll spice it up and do a word problem. If a rectangle has length 7 radical 3 inches and width 5 radical 3 inches. What is the perimeter of the rectangle? Okay, so this one might look a little bit different, but it's the same exact concept that we've been working on this whole time. So a rectangle has length 7 radical 3 and width 5 radical 3. What is the perimeter of the rectangle? So I'm always going to recommend we start by drawing a picture whenever we're dealing with anything like this. Then we know the length, that's the longest side, is 7 radical 3. Well, in a rectangle, you're going to have 2 sides that are that length, so 7 radical 3. And then our width is 5 radical 3. And then using my math vocabulary, I know that the perimeter means the total of adding up all the sides, the distance around the shape. So I'm going to have 7 radical 3 plus 7 radical 3 plus 5 radical 3 plus 5 radical 3. And then I check, do I have the same radical and the same index? Yes, I do. So 7 plus 7 plus 5 plus 5 is going to give me 24. And then I bring down my radical 3. So addition and subtraction, I don't think it's too bad. Hopefully you all don't either. But if you have questions, please make sure you bring those to class and you ask questions, whether you need to shoot me an email while you're at home, or if you're working on homework and you have a question to bring to class tomorrow, either is fine. Please make sure you are taking good notes, keeping up with your notes, asking questions, and if you're struggling, make sure you're reaching out. Hope you all have a lovely day, and I'll see you when I see you.